But the side angle conjecture is easy. Smallest angle opposite smallest side, but it's harder to apply when the triangles are attached. So who has a solution? Or or are you stuck? What do you think, Dylan?
I got G is equal to A, which is less than B, which is equal to D.
G is equal to A, which is less than
B, which is equal to D.
Equal to D,
which is less than E.
Less than E.
Less than C.
Less than C. Less than F. So F is the biggest and G and A are the smallest? Okay, you guys agree? Not sure? It's okay to... Awesome. So, if I were going to try to troubleshoot what you did, Dylan, to see if you were right, can you tell me, did you start with the triangle like on this side, or did you start with the triangle on that side, or did you just... Okay, you should have never started in the middle. That's one thing in a problem like this, because you want to order them, but you also have to treat each triangle separately, which, what's weird about this is G is opposite 30 degrees, right? And so the misconception is it's opposite 30 degrees, so there's no way, well, that's not a good example, like, let's see, I have to look at it, look at your work, because what I'm going to say isn't going to make sense until we look at your work. So, if you worked on the left, you could agree, if I went from smallest to greatest, that G's the smallest, because it's opposite 30, compared to F, but this is isosceles, so this is 30. So we know it's equal to A, and we know that's less than F. So that part I agree with. How about you guys? First triangle, right?
Yeah.
Now the second triangle, pick up where you left off. We started with F. What can we say about that? We know this is 30, and this is 90. So this has to be 60 for the three of them to make 180, so this is an equilateral. Does that make sense? So we also know F and E and D are equal. Oops, I should write that down farther. What do you think? Keep Dylan, question? Do you see what I did? So you must have moved, you got to move through the triangle, like imagine you're walking through, you can't skip over. Your process is this way.
Yeah, I was thinking like, I could only have...
Okay, keep thinking about it. Let's hear what Jake has to say.
So, since it's 90 degrees on the larger,
yeah.
But the last triangle is 90 degrees, so it's 45 degrees.
Right.
So the last angle has to be 45.
So this has to be 45. Right, so the third triangle, so this is like triangle number 1. This row is triangle number 2. Triangle number 3, I'm going to start with the common side since D is in both. I'm going to say D is equal to B because they're both opposite 45, but they're both less than C. And now I've gone low to high. So I'm going to go G equal to A less than F equal to D, E equal to D equal to B less than C. But most people don't get that right the first time. Yes, Dylan.
I didn't know the first ones. I thought that like I was thinking B could like I was thinking like F could only be the top one because for the one at the bottom between angle like the one with 60 and 45, that one. I was thinking like with the 60-degree angle, I was mixing up the two angles of 45 and 60, so I was thinking, well, I mean, F can't be that.
That's
B is already, that's the only one.
Right, and we're saying that B and F are the same length, yet they're opposite, different values. And that's the point of this problem, because the side angle inequality conjecture, this applies to in a single triangle. The smallest angle is opposite the smallest side, but you're in a single triangle at a time. So in a single triangle, the smallest angle is opposite the smallest side. But once you put the triangles together, you have to treat each triangle as an individual triangle. Does that make sense? That's a good test question. Something like that. I'm going to like make a little note of that. I'm going to actually just post that, just because that way